Kia ora tātou, welcome to this video where we will introduce equilibrium reactions. So in previous years we will have only looked at reactions that go to completion. So if we had reactants A and B, so they could be anything, we would always say that that goes into whatever the products are. And once all of the reactants had been used up, we would have all products, and that would be the end of the reaction. And we say that that is a reaction that goes to completion. So what we're going to look at for these equilibrium reactions are reactions that are called reversible. So we can go from A and B to C and D, and we can also go from C and... why did I put B again? We can also go from C and D back to A and B. So this is a reversible reaction, and it's shown by these double arrows there. So this introduces the concept of equilibrium as well. So we get to a point where the amount of reactants turning into products will be the same as the amount of products turning into reactants, and that's called equilibrium. So this is, we call this when we're going in this direction from AB to CD, this is called the forward reaction, and when we're going in this direction, this is called the reverse direction, or the reverse reaction. So at equilibrium, the rate of the forward reaction and the rate of the reverse reaction will be the same. But that doesn't necessarily mean that there's going to be 50% of A and B and 50% of C and D. It could be a vast majority of A and B, that could be like 99% or even more of A and B and 1% or less of C and D, or the other way around. It could be mostly C and D and then the rest could be A and B. So let's do a little exercise to see how equilibrium gets reached. So for this reaction, let's say that the forward reaction occurs that 20% every second, 20% of the A and B, the reactants, turn into products, and then also every second 60%, so notice that they're not even necessarily, per second of the products turn into the reactants. And let's say we're starting off with 100 reactants. So we'll draw this in, we'll do a little graph here. So at time 0, we've got 100 reactants, we've got 0 products. And so the amount of products that are going to, reactants that are going to turn into products is if we take this times 0.2 and then this times 0.6. So 0 times 0.6 is 0, so we're going to get none of this turning back into that. So we can put 0 there. And times 0.2, we're going to get 20 particles turning into products. So the change here is 20 particles going in that direction. So at time 1, if this is seconds, we're going to have 80 particles and 20 particles of C and D. So now this time if we go times 0.2, we're going to equal 16. So 16 particles in this case are going to turn into products, 16 reactants, and then 20 times 0.6 will be 12. So we're going to get 12 products going back into the reactants. So what the change in there will be is 4. So 4 in total are we going to go from the reactants to the product. So after 2 seconds, we will have 76 reactant particles and 24 product particles. So see if you can do this a couple more times. You can just pause the video and see what you come to, see what happens. Okay, so I've just added in a few more. So what we can see is that we're slowly approaching 75 with the reactants, and with the products we're slowly approaching 25. So we can see that the rate of the forward reaction is going to become 15 will be going in that direction, and then 15 will be going in that direction. So the rates of the forward and the reverse reactions are now the same. So at this point, when this finally reaches 75 and this finally reaches 25, we are going to say that the reaction is at equilibrium. So just to show this on another graph to visualize it, so if we've got the graph looking like this, let's say we've got 100 particles on this side, particles, and we might have 75 there and 25 there. So a reaction an equilibrium reaction would look like this. If we start off with A and B, shown by a black line, we're going to see that it starts to get to 75, and then if we have C and D, shown by a blue line, then that will quickly approach at the same rate 25, and then they'll continue on like that. So at this point here, we are at equilibrium. Great, so that's equilibrium introduced. We're going to look at some formulas in the next videos, and then we'll look at how we can kind of manipulate equilibrium a little bit to get the products that we might want out of these types of reactions. So thanks for watching. See you in the next video.